something like this on number one, when it asks for the domain and the range, the domain is your X of your ordered pair. It's always, if you're on a graph, it's moving left to right. If you've got a set of ordered pair, it's your X. To be completely correct, it would go in the squiggly braces, and then you would just list your X's.
Do we have to do this?
5,
every
yep,
year?
I'm doing it, you're gonna do it, 5, 6, 7, 8, so it would look like that. Then range is just your Y's. If you got a graph, it's going up and down. If you're in set of ordered pairs, you just list your Y's. So here my Y's are 5, 6, 7, and 8. And then the last question asked if it's a function or not. There's a few ways you can tell if it's a function. One, no-fail method is a vertical line test if you put them on a graph. So you could do that and then move your pencil across it vertically and see if it ever touches more than one point at the same time. Or if it's a set of ordered pair, it's just real simple on whether or not your X's are repeated. And all that means, it sounds confusing to say, but all that means is this 5 in the X column only has one Y to it. There's not a 5 again anywhere down here. This 6, it's a 1-to-1 relationship all the way through. Nothing's being double dipped there. So then that means, yes, this is a function.
So that's literally our domain.
Uh-huh.
Domain just go X's and these.
Yes. Yes, yes, yes. Yes. Sure. Alright, so what other ones on, you want on 1 through 4? Do you think you,
Number 3. Yeah.
number 3, yep.
And can we do number 4 or no?
Yeah, we can. Everybody's set up for next period.
Function.
Okay, 6, 7, 8. Alright, so on 3, you've got the graph. Okay, so I'm not gonna go get the graph paper, I'll just try to get the basis off of it here. That point that's circled is 1, 1, 2, 3, -3, so it's got a 1, -3 here. And then it's going up this way, and then it touches at -1, 2, 3, 4. 1, 2, 3, 4, 5, yep, -4, 5. Okay, so that's the, graph that you're given for number 3, so our domain, our X's,
Or -1.
the farthest left it goes would be that point right there, which would be -4. And since this dot on -4 is colored in, that means it can touch it. And that was specific in the, if we put a bracket or a parentheses, do you remember that?
Wait, say that again?
If it's got a dot, it means it touches it, and so that tells us whether or not we put our -4 in a bracket or a parentheses.
So the bracket?
If it touches it, it gets the bracket, and then it goes, moving left to right on the domain. The farthest right it goes is right here, which is 1, but it's got an open circle, so it doesn't touch it, so it gets a parentheses. So that's our domain, how far left or right it moved. Okay, then our range is how far up and down it moves, so, the lowest it goes is down here, and how low is that? -3, does it touch -3? No, it's got an open circle, so it'll be a parentheses. How high does it go? How high is that?
3.
No, no,
Oh, that's 5.
5, good, and does it touch 5? Yes, so 5 will get a bracket. Okay, then to tell whether or not it's a function, and this is what I was talking about, when you got a graph, you just do a vertical line test. So I can take any vertical line and put it on my graph and move it left to right, just like I'd read a book, and if it ever touches that graph more than once, it fails the vertical line test and it's not a function. It's like if I started moving my vertical line, it touches it once right there, once right there, once right there. It's never gonna hit at 2 places on my ruler, is it? So that means, yes, that is a function.
So
ever touched my vertical line more than once, it would not be a function. But this one, yes, it is a function.
So if it touches the line, like you move over like 3 spaces, you're in the
We'll look at number 4. What would my vertical line test do on number 4? Yep, because if I put my ruler on that, and started moving my ruler left to right on number 4 here, right now, it's touching my vertical line twice, so no, that's not a function.
So if it's touching both of the lines?
At the same time, yeah.
Okay.
So this is no, not a function. Okay, now the domain, I just drew that real fast, I didn't even count anything on there. But it doesn't go any farther left than that point, which is at negative 1, 2, 3, negative 1, yep. Negative 3, negative 1, so for my domain, farthest left it goes is negative 3, and it does touch that, but then it goes to the right forever. So it'll be something like that. Now the range is easy on this one,
Why do we get a reference?
because it touched the negative 3.
Wait.
You got it? Alright, range is up and down, and this little ugly graph here is gonna keep going up forever, and it's gonna keep going down forever. So you could write your range as all real numbers, or you could say from negative infinity to infinity if you wanted. Either one of those are right. Okay. What do you wanna look at on 5 through 10? Doesn't matter to me.
I think we do
8
5.
first,
I think we do 5.
10, well, no, I'll do 8, because some are wanted 8. So,
6,
I'm
8,
looking at 8, g of x plus 4.
6, 8,
Okay, so since it says g, I gotta make sure that I pick the right function from the top. The g function is x squared minus 8x plus 21. So everywhere there's an x in that, I'm gonna substitute it with x plus 4. So instead of x right here, I'm gonna put x plus 4, but then that squared is still on it. Minus 8, instead of x, I'm gonna put the x plus 4, and then plus the 21. Okay, we went over this when we did it a long time ago, and yesterday while people were working throughout the day, I still saw this mistake over and over again. That x plus 4 squared does not mean you just distribute the squared to both of those. When that whole parentheses is being squared, that means you have to write that whole parentheses twice and multiply it out.
Can you just do 2x plus 8?
Nope, that's not right. So here, when you multiply these out, x times x is x squared.
How do we get that?
Oh.
That's what x plus 4 squared means, you write it twice. X times 4 is 4x. 4 times x is 4x. 4 times 4 is 16 on the last part. So if you combine those like terms there, this first piece that was x plus 4 squared simplifies to x squared plus 8x plus 16.
Where'd you get
Ask me.
your
Ask me.
4x
That's the
plus
answer.
4x?
No, I'm not done, Riley. Where'd I get what, Kelly?
Your 4x plus 4x.
When I distributed this 4 to the x right there, and then this x to the 4.
Oh, okay.
What happened to the negative 8?
Nothing, I haven't got there yet, you're ahead of me. Alright, catching up now with Riley, now we're to this next piece, so we're gonna distribute a negative 8 to both of those. Yeah, minus 8x minus 32, and then bring down the plus 21. Alright, so like terms to combine now. I got an 8x and a negative 8x, that's nothing. Yep. And then I've got a 16 and a negative 32, which is negative 16, right? And then negative 16
5.
plus 21,
5.
it's not a negative 16.
Wait, why wouldn't it be a negative?
It is, you're right, it is, because I forgot we combined it with the negative 32. You're right, very good. So all you got left, Kinley and Riley are correct, negative 16 plus 21 is 5. So all you got left is x squared plus 5.
No, minus.
Uh-huh, that's your answer.
Normally we do.
Hold on, can we have the next one in this section?
10.
10.
I just need to know, you don't have to do it, but you know it's an absolute value, so.
You do have two equations, yes.
Okay.
So we need to do it, sounds like, alright. On 10, says find, if h of x equals 39, find x. So this one, they're not telling you to plug in for x, they're telling you that the whole function is equal to 39. So you go up there and you see what Kinley was talking about, the h of x function is absolute value of 9 minus 3x, and so you just set that equal to 39.
Yeah.
And now some are asking about this yesterday, remember back to the beginning of the year when you've got an absolute value equation, you gotta write two equations. So the first one, you drop your bars, and keep everything like it is. The second one, you drop your bars and make everything on the other side the opposite, so that 39 will become a negative 39. So now you just got your two equations to solve. Here I would subtract 9. Negative 3x is equal to 30. Divide by negative 3, and you get x is negative 10. Over here, when you subtract 9, I got negative 3x is equal to negative 48. Divide by negative 3, and I get x is 16.
That's the easiest one ever. Can we do 6 places? Whatever.
Yeah, but can't you just do a fraction in your calculator? But yeah, we'll do it. Got a calculator.
I can have a number too.
Everybody ready on numero 6? Alright, so number 6, it asks you to find f of 11/12. So I go look at my f of x function. It says that f of x is negative 4x plus 1. So instead of x, I'm going to put in 11/12. So negative 4 times 11/12 plus 1. You can type that negative 4 times 11/12 in your calculator and work it that way, no big deal. I diagonally reduced it, so I knew that was 1 over 3. So that made negative 11/3 plus 1, easy killer. Then you can type that in your calculator, it'll handle it. I did 1 is the same as 3/3 because I didn't have a calculator when I was working it. So negative 11 plus 3 is negative 8. So you get negative 8/3. What is that? 2 and 2/3? Negative 2 and 2/3 if you wrote it that way. Did anybody write it that way? I think that's right.
Yeah, I got that.
Yep, good job. Alright, any more on page uno?
No, absolutely not.
We won't have time to finish the whole thing if we do. Say that again, sweet pea.
Oh, yeah, actually, you don't.
Let's look at number 9 real quick. Numero 9, number 9. Number 9, it says f of x equals 53, so find x. So this is like number 10, we're gonna set the function equal to 53. So I look up there on number 9 and it says f of x is negative 4x plus 1. So negative 4x plus 1 is equal to 53. So now you've got your middle school two-stepper, so you subtract 1. Negative 4x is equal to 52. And then divide by negative 4. And I think you get negative 13.
Yeah.
Good deal, good deal. Did you plug it in somewhere? Is that what you messed up on it? I think that's, yeah, I think that's what you did.
That's an extra problem we have to see. I had a question. I don't know how to do it, but on number 2,
Uh-huh,
so the x's would be our domain, right?
uh-huh,
And the range would be our y.
uh-huh.
Well, we have to put them in number order.
No.
So it would really just be negative 7, 3, negative 1, 3, 2, 5.
Yeah.
For range?
No,
Why not for range?
that's the range is the y's. You just listed the x's.
But I thought it shows an arrow.
Yeah, that's just showing how those ordered pairs hook up. So the ordered pair, negative 2 points to 0, so it would be negative 2 comma 0.
So you have negative 2, comma negative 1.
No. Negative 2 is not pointing to negative 1, negative 2 is pointing to 0.
So 0 would be
Negative 1, negative 7.
negative
Uh-huh. The other, no, but you can look at it and see which ones they're pointing to now, right? Okay, what about on the back of that page? It's the same type of stuff, but what do you, any of them you need to look at?
Yeah.
6, I got 6 first.
Oh, yeah.
6, it says to find b of negative 2 minus a of 12. So my a function is the absolute value of 13 minus 2x. My b function is 8x minus 14. So first thing I have to do is plug these numbers into the right function and get an answer, and then finally I'll subtract those two answers. So b of negative 2, that would be 8 times negative 2 minus 14.
Negative 30.
Okay, so you've got negative 16 minus 14, and that is negative 30.
I'm so confused. I'm sorry, but I'm so confused.
Well, you're,
What is that number on the one below 8?
okay, would you look at the problem on number 6? It's nothing that's not on number 6. Well, that's what we're on. What does it say on number 6? I didn't write anything that's not there on number 6.
Just kidding, I got it now.
Alright, so now a of 12 is gonna be absolute value of 13 minus 2 times 12. So that's absolute value of 13 minus 24, which is the absolute value of negative 9, or negative 11, excuse me, thank you, Kara, that'd have been bad. Negative 11, the absolute value of negative 11 is 11. Good. So then we got our two answers here. So now the problem says to subtract them, and subtract b minus a, so negative 30 minus 11
Oh, crap.
is negative 41. You did all the hard stuff then. Well, we can, but I mean, we just went over 3 and 4 on the front page that are just like them. But- Alright, everybody got what they need there on 6? Okie dokie, on number 4. Draw my little snake graph real fast, maybe. All these y'all keep doing repeats over, it's gonna take time away from the other stuff. Okay, so number 4 says, what is the range? Range is y is up and down. So I would go to the very bottom of this snake graph and count down to see how low it goes. So I'm on my graph on my paper counting 1, 2, 3,
Four.
4, so -4 is the lowest it goes. And then I would go to the mountains here on my snake graph and
-1.
see how high it is. And Austin's right, that's at -1. So my range would include all the numbers between -4 and -1. So to write that, range is your y. So you're gonna say -4 is less than or equal to y is less than or equal to -1. Alright, on number 2, it asks you to check which relations represent a function. It says check all that apply, so there could be more than one. So first thing I did was marked out the second one. It can't be a function, that second one, because if you did that vertical line test that we just talked about, if I drew a vertical line, it would touch it twice, so it would fail. So it can't be that one. Then I noticed on the last one, and that, those are called mappings, those ovals with the numbers on it. On the last one, I noticed that 7 goes with 2 different y's. So if a number in the x, and that's what I was telling you in the beginning, if a number in the x goes with 2 different y's, it is not a function. So then that just leaves the first one and the third one. So on the third one, if I did a vertical line test on that line on the third one, anywhere I draw a vertical line, it's only gonna touch that graph once. So yes, that third one would be a function.
Did you say the last one was no function because you used 7 3 times?
Correct.
So 1 and 2 aren't here?
We haven't talked about the first one yet. So what about the first one? Are any of those x's used twice?
Nope.
No, so the first one is a function. So just the first one and the third one. Some of the y's are used twice in the first one, but y's don't matter.
And then you explain why the 4 is not a function.
Because that 7, the x7 is used twice, and x can't be used more than once.
Oh, and x can have an arrow to 2 y's.
So the first one is not a function.
The first one is a function.
Well, 1 x can have an arrow to 2 y's. Oh no, 2 x's can have an arrow to 3 y's.
Correct.
So it's only the first one, the third one are functions?
Or if the first one you go down vertically.
Alright, what about 7 through 12 on the next page?
Could you do 7 or 8? I
Yeah, anybody cares 7 or 8?
What she said?
She said there's 7 or 8, either one. Summer said 7. So 7 says find p of x minus 1. And then it says p of x is equal to x squared minus 7x. So same as earlier on the first page, we're gonna take x minus 1 and plug it in both of those places for the x. So we'll have x minus 1 squared minus 7 times x minus 1. Now, same as on the first page, you can't just distribute that squared. When you've got a whole parentheses being squared, that means you write it twice and multiply it out. So that'll get me x squared minus 1x minus 1x plus 1. So then minus 1x and minus 1x right there makes this piece be x squared minus 2x plus 1. Now before Riley asks, we need to go to the -7, right, Riley? Distribute that. So it's gonna get me minus 7x plus 7. And then we'll combine, we got a -2x and a -7x, -9x, and then we got a 1 and a 7. Where should I know? Yep.
Sophie,
Uh-huh.
Can you tell me if my number 11 is right?
Yep.
I got y equals 4 over 3x times 2.
Yep.
Okay, and then it's my 12 y equals -1/2 x plus 1.5.
how do you know?
What was that? homework while you're
Is
going.
number 11 C?
Yes.
Oh, and is number 12 A?
Anything else on this page? We're doing okay still on time. I just wanna try to get you as much as you want.
I have one.
Okay, hold on, we're gonna look at 9. Sit around, Kim. I bet you a lot of y'all missed number 9.
I didn't even try it.
Equals. Okay, so number 9, it says write in standard form. So the first deal about standard form, you gotta have the x and the y, ax plus by equals c. You gotta have the x and the y on the same side and the number without a letter by itself. So I would need to move that 5, 6x over there. So to do that, anytime you move across the equal sign, you gotta make it the opposite, so it's gonna be a negative 5, 6x. So I'm gonna put it in the order here, negative 5, 6x plus 8/3 y equals negative 2. And I'm gonna bet, I may be wrong, hopefully I get proved wrong, but I'm gonna bet everybody that tried number 9 stopped there. Good, way to go. I was hoping I was wrong.
But you can't have a fraction.
Can't have fraction, can't have a negative. So I gotta think about what I can multiply this whole thing by that'll cancel out the fractions and the negatives.
We just divided by -1 to get a negative.
I think I can multiply it all by negative 6, because 3 and 6 will both go into 6, right? So negative 6 times 5, 6. The 6 just cancel out, so I'll have 5x. Then here, and you can type these fractions in your calculator if you don't trust my fraction magic. This will be negative 16y, because what happens on that, the 6/3 reduces to 2, so 8 times 2 is 16. And then that will equal positive 12. So that would be your answer for that one.
How would you graph that though? Since it's not a fraction.
Well, if it says it's in standard form, your choices for graphing it are to solve it for y and put it in slope intercept, or plug in zeros and graph the zeros.
Do we have some on the test that are like that where we have to, after that, put into a different intercept to graph it?
I don't remember it being on there, no. All right, Kelly, was yours on this page? Did you? Okay, any more on this page before I flip it?
Can you tell us the answer number 10?
Y equals 7/3 x plus 2. Good job. All right, Kenley's got first on 13 through 19.
What's that? I got what?
You get, I thought you had one you wanted me to do really bad. We're on
Yeah.
the page with numbers 13 through 19.
Yeah, number 15?
Okay. On 15, give an example of a linear equation that's parallel to the y-axis. So there's actually an infinite amount of answers for this. So the y-axis is your axis that's going up and down. So to be parallel to that, I would have to be another vertical line somewhere. So to name those vertical lines, they don't have a slope. So this one would just be like however far over that is. So like this one could be x equals 4, x equals 7, x equals negative 3, x equals negative 6. So there could be a ton. The only thing that I would have to check for when I'm grading this is to make sure you didn't put a y in there.
Oh, okay, thanks. That's a lot easier than I thought.
I mean, you could put 0 y if you wanted to. You could put it that way.
We circled 14 yesterday.
Okay, 14, which of the following lines is perpendicular to negative 9x equals 15 minus 3y. So when you're dealing with perpendicular, that means the slopes have to be the opposite sign, positive or negative, and they gotta be reciprocals. So first thing I would need to do is figure out the slope of this line. So when I did that, I just wrote it in slope intercept form, which means get the y all by itself. So first thing I did was subtracted that 15 over, so I had negative 3y equals negative 9x minus 15.
What form are we putting this in again?
Well, I'm working on getting it to slope intercept form.
Okay. And what's the equation for slope?
Y equals mx plus b. Now I'll just divide everything by -3.
And that would give me y equals 3x
Uh-huh.
plus, or,
Uh-huh.
yeah, plus 5.
So we know this line has a slope of 3. So our perpendicular sign, since that one's positive, our perpendicular line would have to be negative. And then you would have to take the reciprocal of 3, which is 1/3. So we're looking for those choices on number 14 that has a slope of negative, that's an ugly, you almost got like 17 humps, -1/3. That's gonna be what's important to us. Okay? So,
I have a question. Wait, why 1/3 and not 1/3?
the reciprocal of 3 is
Oh.
1/3.
What is this one?
Flip it,
Okay, why did we flip it?
because perpendicular lines have opposite reciprocal slopes. I didn't make that rule up.
Okay.
Alright, so we gotta go through A, B, C, and D and figure out which one of them has the correct slope, which is -1/3. So you just have to start through. Do you think you know one, or you just want me to start on A, or what?
C.
Okay, I heard C. Let's see what the slope of C is. 12x, does that say equals? I've scribbled on mine.
Equals 4y.
Minus 4 equals 4y. Okay, so this one's almost solved for y. To find the slope, all I would have to do from here is divide everything by 4. So that would give me 3x minus 8 equals y. So its slope is 3. So it's the same, which means parallel. I'm looking for perpendicular. So we can mark C out.
Perpendicular is like,
Intersects at a 90 degree. So C's not gonna work for us. Pick another one. A, B, or D? A's got 6x plus 2y minus 8 is equal to 0.
Coach Wright, can you send Riley Rogers to the office?
He went to the nurse's office.
Thank you.
So I'm gonna subtract the 6x over, and I'm gonna add the 8 over. Now I'll just divide everything by 2. So that gives me y equals 3x plus 4, so again, its slope is 3, so it's parallel. So that one's not any good. So we know it's not A or C, it's gotta be either B or D.
Let's try B.
Go B. Alrighty, let's see what B gets us. B, I've got x minus 3y equals, is that a -3 on B? I've scribbled on it.
yeah.
Okay. Alright, so I would move the x over, so I'd have -3y equals -x minus 3. And then I would divide by -3. This one almost works, because that would give me y equals, and this is gonna be where my x divided by 3, that's gonna give me the 1/3 that I need, but a negative by negative is a positive. So these are just neither. So it better be D, huh? Let's do D to make sure I haven't screwed up anywhere, because that's highly possible. D has got 6y equals 42 minus 2x. So it's almost got the y by itself, just divide everything by 6. So that gives me y equals 42 by 6 is 7. -2 over 6 reduces to -1 over 3. So that one does have the -1/3. So it was D on number 14.
So you also have to change the sign if it's perpendicular?
Perpendicular, you have to, opposite means positive or negative, opposite sign, and reciprocal, yes.
Maybe number 16.
We got about 13 minutes, so number 16. Uh-huh.
Maybe not 16.
Yeah.
We can just
Okay.
go.
Not, well, I'm just tell, I don't wanna scare you into not doing one, I just want you to know we're on a time. Right, 19, do y'all need 19, someone wants to do
Yes.
19? So 19, Angela fully charged her laptop, then unplugged it and tracked the battery level at certain times under constant use. The table shows her findings. Find an equation for a line of best fit, then estimate the battery level after 2 hours of constant use unplugged. So this is when we did scatter plots, when we did this. So you can graph them and put a line of best fit on there if you wanted to. I just picked 2 points off the table and found the slope from there and started, because if we can find a slope and a x1, y1, we can plug it in to this point slope formula, which is what you would do on one of those that you were asking about, Kira, I think. So, I did, 210, which would mean an X of 10, because it's 10 minutes after we started studying it at 210 and 94%. And then I did 240, the office called for you, which would be 40 minutes, and then it's an 83%. So I can use that to find my Y, my slope. So I'm gonna subtract my Y's on top.
On this one, doesn't matter which one you choose, right?
No, you could choose any two. Subtract my X's on bottom. So that gets me 11 over negative 30, and that doesn't reduce, so my slope is just negative 11/30. And that should make sense, it's a negative slope because your battery power is going down over time.
Would that be our equation or solution?
No, that's just our slope. We haven't got any equation or anything yet.
What number is this?
19. So now we take our slope and we take one of these 2 points over here and plug it in a point slope formula so we can start getting that equation. So I'll just use that first one, it doesn't matter. Y minus 94, that's my Y1, equals my M times X minus 10. So that gets me, when we start cleaning up, Y minus 94 equals negative 11X over 30 plus 110 over 30. So then my last step would be to add the 94. So that gets me, I don't know why I wrote 99 right there.
Wait,
I'm listening.
I don't know.
Okey-doke. That gets me Y is negative 11X over 30 plus, I don't know what 110 over 30 plus 94 is, do y'all?
No.
Can y'all get it on your calculator faster? 10 over 30 plus
293 over 3.
That's what I got, sir, thank you. 93 over
Okay, got this one.
3. So there's your equation. Okay, then the question, the solution that it talks about, it asks for estimate the battery level after 2 hours of constant use. Well, our X that we've been using is in minutes since 2 o'clock. So 2 hours since 2 o'clock will be 120 minutes. So you're just gonna plug 120 in for your X. Okay, I got my fraction.
425 over 3.
No, that's not what I got. I got 161 over 3, which is about 53.7. See how you typed it if we did it different. So that, what that says is after 2 hours, you'd have about 53.7% of the battery left. Your 11 was, that left side was supposed to be negative.
Oh, I see it now.
The equation was this one. And then this one is the solution.
161 over 3.
Yes, good.
How much more time do we have left?
About 8 minutes.
Okay. Do we skip the next page?
Well, if somebody wants one on there, we redid a bunch for some of y'all on the first ones. We're on 20 through 24 with about 7 minutes left. What do we need on there? And remember, you don't have to follow the directions. You can solve the system using your favorite method.
Are we gonna be able to do that with this?
Yes.
Oh, yeah.
Anything? I got have time to do one or two off there before we move to the next page?
And do we have to graph it?
No, you can do it any of the methods you want.
What's the infinite solution?
True statement, same line, 7 equals 7 as an example.
Did we do 23 or 24?
23 or 24, anybody care which one of those? 24. Okay, here's choice A, because this is one of those where you just have to start through the choices. So an infinite solution's what Riley just asked to be an infinite solution. When we made our notes on this, I gave you the example of you graph a line, and then here comes the second line, and it's exactly the same. So what that will look like as far as solving these, if that's how you choose to do it, is you'll get a true sentence like 8 equals 8 or 7 equals 7, or you could just put them in the same form and see if it's the exact same line or not. Okay, so like on this one, I can tell this is not it, because if I move this 2x over to make them in the same form, that's going to give me y minus 2x is equal to 5. Well, see, those aren't the exact same, are they? This one says y equals 2x minus 7. That's not exactly the same as y equals, I know why you're confused, I put my signs wrong. Y equals 2x, negative 2x minus 5. If I move that 2x over right there, y equals negative 2x minus 5. And so to be infinite, it's got to look exactly the same, and those two that I've got linked up don't look exactly the same. The 2x's are different, and the 7 and the 5 is different.
Can we put these in solve?
You can, or you can solve them and see if you get a true statement, either way. Okay, on choice B, I got x equals 3y plus 15, and then I've got 12y equals 4x minus 60. Okay, so if I wanted to line these up to kind of compare them like I did on the last one, I would need to switch x and y, right? So that top one would be negative 3y equals negative 4x plus 15. Okay, now as it stands, it's not negative 4x, dumb butt, that was a 1x. Why did I write 4x? Because I'm a silly, losing my head now. Right, so as it stands, those don't look exactly the same, right? But what if I multiplied all of this equation by negative 4? Is it the same equation? Negative 4 times negative 3, that's 12, ding, ding, ding. Negative 4 times negative x, that's 4, ding, ding, ding. Negative 4 times 15, that's negative 60, ding, ding, ding. So it's exactly the same, so the choice is B. Other way you could do that is to just solve the system, either by substitution or elimination.
But that's not the answer.
Why did,
B is the answer, yes.
why did we multiply last time to see if that multiplied?
Because what would we have multiplied? We had a 1y already. So what would we have multiplied by that would keep it the same?
No,
So we couldn't. I mean, if we multiplied this by 2, you'd have 2y minus 4x minus 10, 2y plus 4x minus 14. It still wouldn't ever be the same. All right, anything else on 20 through 24?
23 too.
23?
Yeah.
Okay.
I'm not gonna do that.
Okay, so your options for solving this, substitution, elimination, or graphing, it doesn't matter. I did it by substitution, because the first one is almost ready. But how are you gonna do it tomorrow? That's what I need to do right now.
This one's supposed to solve by elimination.
I know, and I told you you didn't have to do it that way if you didn't want to. It's up to you. It's 23.
I would personally do it if I don't.
Okay, so I need to move over stuff. So I would have 8x plus 2y equals negative 24. And then I would have 6x minus 5y equals 18. So I've got them lined up now, but I still don't have a variable that's the same. So which variable do you want to eliminate?
What one do we put in?
I just put it in standard form.
What'd you ask?
What letter do you wanna eliminate?
I don't really care, 5Y.
Okay, what do I do?
Multiply the bottom equation by 2 and
Okay.
top equation by 5.
Okay,
Oh, yeah, making the same.
so that's gonna get us 40x plus 10y equals 24 times 5, negative 120. Here I'm gonna have
What?
12. Did I do something wrong, Austin?
I did.
Okay, 12x minus 10y equals 36. My y's are different signs, so that means I add. 52x is equal to negative 84.
If it was, like, negative 40 and then x and then 12x, we would subtract them.
The,
Like before.
the letter you're getting rid of, if it's got same signs, you subtract. If it's got different signs, you add.
Oh, so it's the y?
The letter you're getting rid of. I think something's wrong.
Yeah, I think I could do this one.
40. 24 times 5.
I think I know what it is.
Tell me. Minus 10, 36.
Oh, we did.
So that's right. 6x minus, oh, I see what it is. When I moved that 18 over, it should have been a negative, so this will be a negative 36. So negative 120 plus negative 36 makes that negative 156, not negative 84.
And then we divide that.
And then divide that by 52, yes ma'am.
That's 3 equal.
Yep, negative 3.
And then you just.
And then you just plug that back in to get a y.
Thanks for going over some of it with us.
Well, we got a lot of it done. Okay, so you'll be able to use notes, you'll be able to use study guide. So have all those ready tomorrow.
We still have all weekend to do the study guide and stuff.
Yeah, you'll be all right. You'll be all right. Tomorrow's Saturday.
They never been.
You at work all weekend? Ooh, doggies.
Gotta be there by 7 in the morning tomorrow.